Welcome back, Chemistry 1 students. Today we are going to see how pH and hydrogen and hydroxide ion concentrations go together. So the first thing is, what is pH? The negative logarithm of the hydronium ion concentration, mathematically represented by the following equation. Very technical. Here we go. The following equation is simply this. So some of you may be taking a math class where you've actually talked about log. Some of you have actually looked at your calculator and you've seen a button that actually says log, log. So what's something to keep in mind, the beginning of this is going to be really simple as long as you have a scientific calculator with you. And any scientific calculator, I think even the ones on your phones, will do logarithms. So the first thing we need to understand is also we've got this negative sign. Basically what this means is that whatever you put in for your log, if it's going to come out negative, you simply multiply it by -1 and it'll make the number positive. We can't actually have a negative concentration of anything. Either we have a concentration of some ion or it's just not there, but we can't have a negative concentration of an ion. So never put down a negative concentration. So first of all, a little bit of review for what we talked about or went over yesterday. A solution with a pH less than 7, pH less than 7, actually we didn't talk about this, but you should have talked about it in a middle school class. But if it's less than 7, it's actually considered acidic. If a solution has a pH equal to 7, this is going to be neutral. And if the pH is greater than 7. So does anybody know how high the pH scale goes? 14. So between anything greater than 7 up to 14 is considered a basic solution. So example 4, what is the pH of a solution with a hydronium ion concentration of 4.2 times 10 to the minus 10th molar? So all I'm going to do is get out my calculator and I'm going to type in my number. Now, depending on what type of calculator you have, some of them you hit the log button and then you would type in 4.2 times 10 to the minus 10th, and others are you type in this first and then hit the log button. Again, you need to get familiar with your calculator and figure it out. So honestly, can't remember which one mine is, so I'm just going to give it a try. Mine looks like I actually type in the log button, and now I'm simply going to put in 4.2 times 10 to the minus 10th. And that will give me negative 9.37675071. Okay, so a couple of things with this number. I never want to see a number that big. That's ridiculous. And if you want to know how many significant figures you should have, well, there you go. There are 2 out in front of here, so your answer should have 2. The other thing that's incorrect with this right now is that I didn't multiply it by my -1. And again, there's never a negative on the pH scale. It goes from 1 to 14, so we don't have any negative numbers. So the real answer to this is actually going to be 9.4. Now, there are no units on pH, so whenever you're calculating a pH, it's simply going to be a number. And I think that's probably about as confusing as it gets. So at this point, you may actually want to stop the video for a couple of seconds, work through some of the examples I've given you, and then check them to make sure you're correct. So after working out the problems, here are all the answers for each one. Yes, I know this is incorrect significant figures. This should actually be 1.4. But everything else seems to have the correct number of significant figures. If you aren't coming up with those numbers, now is a good time to send me a message or go back and rewatch what I've done already. Oh, by the way, I don't know if yep, 9.4, there we go. So now we're down here to example 6. The pH of an unknown solution is 6.35. What is the hydronium ion concentration? So here's where things are going to start to get a little bit confusing, because now we're given the pH and we have to find the hydronium ion concentration. So here's where understanding algebra and understanding what is the inverse of something actually means. So if we were talking about addition, the opposite of addition is subtraction. If we talk about multiplication, the opposite is division. But if we talk about log, what's the opposite of log? And so you go, well, I don't know. It's actually called anti-log. The really nice thing about scientific calculators is that they keep the inverse properties or the inverse functions usually together on the keypad. So what you're going to notice is that if you have a button on your calculator that says log, right above it, you're going to have something that should look like this. 10 to the x. This is actually the opposite function of log. So what we're going to be doing is and you're going to have to probably hit that second button up here on the corner so that way you can actually get to this function. So first thing I'm going to do is I'm going to set it up, and then I'm going to kind of work through algebraically how do we get backwards. And for this I'm going to need some extra room over here, so let me just erase this. First of all, our original equation starts off as pH is equal to the negative log, and I'm just going to do this for simplicity's sake, know that that's the hydronium ion concentration. So to rearrange this, the first thing we would do if we talk about order of operations is we need to get rid of this negative sign. So if I divide both sides by -1, that gets rid of the negative over here, and that basically just makes this negative pH. Okay, so I'm just going to erase this. We've gotten rid of the negative sign. So now to get rid of log on this side, we can't simply divide by log because division is not the opposite of the log function. It's the inverse or the anti-log, right? So what that looks like instead is if we take 10 and raise it to the power of log of something. That's how we get rid of it. On the other side, that's exactly what we have to still do, again, algebraically, right? So now what we find out by doing this, 10 to the negative pH, will actually give me the hydronium ion concentration. Let's write that back in there just so there we go. So the hydronium ion concentration is equal to 10 to the negative pH. Okay, so now that's not too bad. So if we know that our pH is 6.35, I'm going to want to put in 10 to the negative 6.35 and hit enter. Or what we're going to do on the calculator, at least as far as mine is concerned, is I'm going to do my second function, 10 to the x, or 10, and mine has a little caret up there, and then I'm going to enter in negative 6.35 and hit enter, and I have this crazy long number that looks like this. Now, that's an acceptable answer just like it is, but just know that this is not how I'm going to write the answers on the answer keys. So I want to actually put that into scientific notation and again, round it to the correct number of significant figures. This number has 3 sig figs. Okay, this one so far has 3 sig figs as well. When we move the decimal place, I'm going to move it 7 times to the right. So this now becomes 4.47 times 10. And when we move it to the right, it's -7th. And you need to make sure you put your unit. Because we're looking for a concentration, we're looking for the molarity. I rounded my answer to an incorrect number of significant figures. Sorry. But 4.5 times 10 to the -7th. Okay, at this point, you may want to pause the video again. Try to work through example 7. Make sure you're getting it correct. And then after you work through all of them, start the video over and see if you got them correct. Okay, so again, we can see I haven't necessarily rounded all of my answers to the correct number of significant figures. I definitely need to work on that in the future. But 1.00 times 10 to the -5th would actually be correct sig figs. If you can't see this at home, sorry, I just love this blue color. 1.5, oh, there should be 2 more figures up here, times 10 to the -13th molar. 1 times 10 to the -4th, and then 2.8 times 10 to the -12th. Okay, on to the last part, and this is also going to be kind of difficult as well. And there are a couple of ways that we can get around how to answer this question. Because this is asking for pH, you have to have the hydronium ion concentration. You have to have one of those. This is actually giving us the hydroxide ion concentration. So we can work this a couple of different ways. We can, by using Kw from yesterday's lesson, convert this into the hydronium ion concentration and then put that number into our pH. Or we could calculate something called the pOH, and then once we find the pOH, we can convert that into pH. So I think doing it the second way is probably a little less confusing, so let me give you another equation. pOH is equal to the negative log of the hydroxide ion concentration. So it's really not that difficult now to find pOH. And you're like, how do I convert pOH into pH? Well, funny enough, pH plus pOH is equal to 14. So now, once you find out what the pOH is, you can subtract that from 14 and you'll get your pH. So I'll write out all my work. We'll see how this goes. What is the pH of a solution when I'm given the hydroxide ion concentration? So first I'm going to put it into my pOH equation. And I get and we need 2 significant figures, so it turns out to be 3979, right? 3979, which actually rounds to 0.40. And now I'm going to subtract that from 14, so 14 minus 0.04, and I should get, 0.4, 13.60. And so let's make sure we check our answer, 13.6. And if we really wanted to round consistently to, well, actually, This would have been fine because now this is a subtraction, and we round it to the number with the least number of significant figures, so technically that could be 14. So, all right, the long answer to everybody's question is, does she really care about significant figures? As far as pH is concerned, I don't. So, this would round to 14, and that just kind of sounds a little bit crazy. I would rather see something like 13.6, to be honest. All right, again, you may want to stop the video and work through example 9, and I'll show you the answers to that as well. And there you go. Hopefully you can read that. We've got 9.6, 3.65, 5.7, and 10.9.